Hey YouTube, I am Tiberius and you're about to watch an edited recording of a Twitch stream. You can check out my Twitch using the link in the video description. If you enjoy the content, please consider giving it a like and subscribing to my channel. Thank you and enjoy the video. Okay. Let's load this. And what we'll do is we'll set... What am I doing? Why am I... It's not like I use burp every day. How do I add a scope? Alright.
Thank you for following.
Hide all those, that's rubbish. Okay. So. Alright, chat. Let's say that you have a post request. Here is a post request. And you have some content. Actually, let's just do user equals admin. Alright. So, if you're a web server, you expect to get lots and lots of... Why is it HTTP 2? That's weird. Anyway. It's HTTP 1 now. Why does it switch? Oh, come on. No, it's not that way. There we go. Anyway. When you're a web server, you have to deal with a lot of requests. Okay? Sometimes these requests will come over the same connection. Okay? Generally speaking, what happens is sometimes when you load a website, like you load this website, right? This website has a lot of things on it. This website, when you load it the first time, you're going to make a request to just slash, right? Which is what we did here. And it's going to return a bunch of extra things that the website needs. Okay? So, the HTTP request, or the browser, sorry, is going to potentially send a lot of these down the same connection. Okay? Now, if you're dealing with a web proxy, they don't do that. But let's just say that it's easier to open a connection to a web server, say, hey, can I have this? Like send a GET request for this, then send a GET request for this, then send a GET request for this. All down the same connection. And you'll get 3 responses back. Web servers can do this. But in order to do this, they need to know how to separate requests out. Okay? I don't understand quite why this didn't work, but it might just be the way they've set this up. So the way that it works, expect to close, is you've probably seen the content length header, right? If an HTTP request has a body, which this one does, this thing, it will set a content length header, which just counts the number of bytes. Okay? So this one says, by the way, this request has 10 bytes. There they are. So even if you had a GET request appended here, let's just do it. Right. If you receive this as a web server, how you're going to parse this is you're going to read the first line, make sure it's valid. The first line should have this syntax. Then you're going to read basically all the way down until you encounter an empty line. And everything you've just read are headers. Okay? So you're going to parse the headers, you're still at the empty line, and then you're going to see if there's a content length. And in this case there is. It's going to say, hey, I have a body, it's 10 bytes long. So I'll say, okay, I'll read the next 10 bytes. And that's it. That's the entire request, and then it deals with that request. And now it goes back, once it's dealt with that request, it goes to the next one. So its cursor, let's imagine it has a cursor, is right here. So it reads the line, makes sure it's valid, which it is, reads the next number, reads until there's an empty line, which is here, checks for a content length header, there isn't one, so it knows that there isn't a body in this request. Okay? Request smuggling works on anything, but technically you ideally need a post request to smuggle. So there is, however, another way of doing it, which is in the HTTP spec, which is called the Transfer-Encoding header. Okay? And there are a few settings for this, but the most used, I think, is chunked. So how does chunked work? Well, you have the blank line. Shouldn't be a line here. You have a blank line. So there's the blank line. And then on the next line, you define how many bytes are in the next chunk. So you can split a request up into chunks. All right? So let's see how many bytes are in this one. This one has 10 bytes, which is, you have to do it in hex. Okay? So this is just going to be an A. And then you have a new line. And then you have to end with a 0 length chunk. Okay? It's easier if you do this, actually. Basically, you have the chunk length followed by a new line, the amount of bytes you specified in the chunk, a new line, a blank line, and then the number of bytes in the next chunk, which in this case is 0. You still have to have a new line, and then you still have to have an empty line. Okay? So the question then becomes, okay, what happens if you do have a content length and a transfer encoding? Yeah? Because if you have this, you could technically do something weird where you could specify a content length which didn't match up with how many bytes there were in the chunk, or vice versa. You could have a content length that was right, but the chunked stuff isn't. So what happens? Well, the HTTP spec says, hey, if there are a transfer encoding header and a content length header, you should use one. So the transfer encoding is what the spec says you should use. And as we all know, chat, if there's one guarantee in the universe, it's that everybody follows the spec. Isn't that right? Absolutely everybody follows the specification to the letter. Nobody does anything different for any reason. We're fine. Yeah, not the case. So, what happens is you have these instances where even when you get two headers, one server might read the content length header instead of the transfer encoding, and one might read the transfer encoding header. Okay? And so this requires possibly a little diagram. Maybe I'll just use the one from my course because it's a bit easier. Alright, so basically this works when there are multiple web servers or devices, I'm going to call them, or services, chained together. Okay, so in this case we have a user, which is the browser, sending a request. Firstly, it hits the load balancer. Then it hits, so the load balancer sends it to the web application firewall, and then the web application firewall sends it to the web application server. Okay, and then the responses come back. But crucially, the load balancer is being clever. When it receives a request, it doesn't just immediately send it to the web application firewall. That would be silly. What it does is it waits, because it has so many requests coming in from all different users, right? Imagine there's 1,000 users here. They're all sending requests, right? So what it does is it collects requests from all different users. And then it packs them all together, one after the other, into a nice big string. And it sends that to the web application firewall over the same connection, right? Like I said before, like, you can deal with this, that's fine. Okay? And then the web application firewall will do the same thing. Okay? So the web application firewall will process those requests, and it'll generally send them again over the same connection. It might pull some and send them over the same connection to the web application server. Okay? And the same works in reverse, basically. So it understands, hey, I'm going to bunch a bunch of requests together, process them, bunch them back together again, process them, send them on, blah, blah, blah. Okay? So that would be fine. But let's imagine, right, that the load balancer, well, actually, so let's imagine the web application firewall, it reads the requests, and if it finds a content length header and a transfer encoding header, it uses the content length header, right, to determine the length of the request. But the web application server, when it gets two of them, it uses the transfer encoding header. So this is basically what HTTP request smuggling does. We basically can exploit this. So what's the actual thing we need to do here? Let's go back to this. We need to smuggle a request to the backend server, so the next request processed by the backend server appears to use the method gpost. Okay, so we can do this here. So we're going to have two headers, content length and transfer encoding, and we need content length to update. That's going to be fine. The first server is going to read the content length. We need the first server to read the entire body. Okay? But we want the second server to only read some of the body. And what's left is going to be prepended to the next request in the queue. Sorry. Okay, so what we're going to do, we need to smuggle a G onto the start of the next request, which is going to be a post. So it rejects requests that aren't using the get or post method. So actually, let's have a look. We send this again. So if we do a G post, get rid of this. Only methods get, post are allowed. Okay. So the front end server is saying this. So let's make this a GET request. GET request returns that. So how are we going to do this? We are going to smuggle a G. Oh yeah, we need a post. Sorry. Make it a post request, should be fine. We're going to smuggle a G onto the next request. So first thing we'll do is we'll put a G there. Okay. And we need basically we want to write a transfer encoding. We want to write in transfer encoding, but basically add data at the end that doesn't actually make it. So we'll put a 0 as the length of the chunk, and then we should just be able to do that, I think. Yes. So basically, we've told the content length is going to update, by the way, when I click send. That's fine. It's going to send all this. The second server, right, is going to get this. It's going to ignore the content length, and it's going to read transfer encoding chunked. And so it's going to go, and it's going to say, okay, how many bytes are in the first chunk? 0. Okay, I will read these 0 bytes. Technically, there's 5, but whatever. It'll basically, it reads the 0, it reads the new line, and then it reads the empty new line, right? Every chunk has to end in a blank line. So the first server is going to read all of these bytes. The second server, when it receives this request, is going to read all of these up to here. And this G is going to be left dangling. And so this G is going to get prepended to the next request we send, which will be here, this one. Does that make sense? So let's see it in action. We'll click send. So we posted to slash, we got it back. Okay, we got this all back. That's fine. Now if I post this again here, hopefully, yeah, there we go. Unrecognized method gpost. So it might be easier to show if I copy this request. let's just get rid of some of these. These headers don't really matter. Let's get rid of all of these. We'll get rid of these as well. Screw it. Oops. Okay. We're going to go back into here. So just imagine that this request was sent, right? And then this request, which again, I'll just take out all this crap. We don't even need this content link, actually. No, we do. It's a post request, sorry. Okay, this request was sent immediately after by just another user. Could be any other user. Okay? So both these requests arrive at the first web server. And the first web server looks at this request, right? It reads the first line, so okay, that's good. I'll read all the way down to an empty line. Okay, was there a content length header? Yes. Oh, there's a transfer encoding header as well, but I don't like the spec. I think the spec is wrong. I'm going to read the content length. The content length is 6. So I'm going to start here, right? So it's already read the empty line, and it's going to count 6, right? So 1, 2, 3, technically that's yeah. It's in LF mode, so hang on, let's just change it to CRLF. So it's going to read what should be 6. Yes. You might be able to see that down. Oh, no, you can't. I'm in the way. Can you see that? 6 selected. All right. There's some invisible bytes. There's basically a /r/n, another /r/n, and then a g. All right. So if you count the bytes here, it's probably easy to see. There's only 6 bytes, right? The /r is a byte. The /n is a byte. So there's a 0. There's a /r/n/r/n, and then a g. Okay, that's 6 bytes. So that's where you got the 6 from. Okay, so the first web server is like, okay, this is one request. I'm going to store that in, I'm going to basically write that into memory. But I'm not going to send that to the second server because that's only one request. I don't want to do that. I want to send another request. So then it says, okay, well, this is the next request in the queue. And so it reads the header. It reads the first line, sorry. It's a post request, good. It reads all the way down, all the headers, all the way down to an empty line. And it says, was there a content link? There was. It was 0. Great. So I'm going to read 0 and append that. So the first server sends all of this, and it correctly gets the 2 requests, right? This was one request that it understood. This is the other. The first server is okay. But now it reaches the second server. The second server receives all of this at once. It reads it's a post request. Okay, it reads all the headers down to the first empty line. Okay, was there a transfer encoding header? There is. It says chunked. Lovely. Oh, there's a content link header as well, but I'm a good server. I understand the spec. I'm going to ignore this, and I'm going to rely on the chunked header. So it's okay, so I'm here right now. Let's read the first chunk. How many bytes are in the first chunk? 0. Oh, great. Okay, so I'll read, technically I'll read the new line characters after the 0, and I'll read the new line characters right after on the blank line, okay? So it's going to read 5 characters. It's going to read the 0, it's going to read the 0, it's going to read the 2 new line characters, oh, the 2 line break characters, I guess, and then the other 2 which make up the blank line. Okay, so it reads that as the first request. So let's actually just delete the first request. All right, that worked. So that's all the bytes it read for the first request, and now this is the second request, and now we have a G post instead. This is used to hack anything that's a web server. This is a web server issue. Are there any specific cues that gives you an idea of when this is possible in the wild? No, it's basically just simply trying it, unfortunately. You just have to keep trying it. Why do some servers like transfer encoder? But I mean, transfer encoder header, if there are 2, transfer encoding is what you're supposed to use. Yeah, but scanner looks for this automatically. But I still advise installing the request smuggling extension. Okay. So it's a I mean, it's not even really a configuration issue. I don't think there are configurations for doing this. It's just built in generally. I don't think there's a switch. The spec says you should, if there are two headers, the content length and the transfer encoding, you should always use transfer encoding. The fact that some servers do it differently, I'm not sure if it's fixable. It might be in some methods. I know some servers have actually patched this. So let's do it the other way around. So that in that instance, so it's the way we classify these vulnerabilities, because it's two servers that are misconfigured, we classify it with what the first server did versus the second server. So in this case, the first server read the content length and the second server read the transfer encoding. So we call this kind of request smuggling as CL.TE. Okay? But let's do the reverse. So where you have TE.CL. Okay. So TE.CL is slightly more complicated. What do we need to do in this one? We just smuggle a request to the backend server, so the next request is a gpost again. Okay. So this is the server. We're going to send x equals x. I usually use x equals x just to make it into just something I can mess with. Okay. So the reason this is slightly complicated is, let's imagine a post request. Post example.com. We'll leave the content length set at x for now. And we'll have transfer encoding chunked. Okay, so we have this request, and the first server is going to read chunked. So if we do the same thing as before, right? 0, and then do a G. Yeah, remember that's how we did before. We want to smuggle G post. So we want to smuggle a G onto the next request. You gain anything? You can gain a lot from this. Maybe we'll do something once we've gone over the basic examples. So the first request is going to read the chunked header, right? So it's going to read a 0. So it's not going to include this, right? That's bad, because that just leaves that dangling there. Okay? So we can't use that method. So what we have to do is we have to make the first request read all of this, right? But the problem is, even if we said, okay, well, that's 1 byte. Yeah, that's 1 byte there. Remember what I said? Every chunk has to end with a 0 chunk, a 0 length chunk. So even though we can technically do this, we have to put a 0 at the end, right? And we have to also end with another new line. So generally speaking, the only way of doing TLCE smuggles is you have to write the entire request. So we would have to do gpost HTTP 1.1 post example.com, and then we can do a content length. Because we don't really care. We know the second server reads the content length, so we'll put that as y. And then we can do just x equals x or something, right? And so now we would count all the bytes here. I don't know how many there are. Say maybe 70 or something. Convert 70 to hex, and then we would do that. So actually, let's just do this now. Let's get rid of all these crappy headers. All right, I'm going to send this request. So now we don't actually have to change this. Okay, so we can keep a get request here. So what I'm going to do is we're going to write post HTTP /1.1. All right, so we're going to do a host, but we're going to use content length. I think the HTTP2 should be okay. We'll figure it out. Let's just do x, and we'll do x equals x. So let's do 3. And then we need a 0 length. I need to... Okay. So after this, we're going to have how many bytes we want to send. Oh, what am I doing? God, this is confusing. Okay, so here, yes. Now we need how many bytes. So we're going to read all of this down to that, which is, luckily, the inspector tells you in hex now. So it's 6B. So if we put a 6B here, that should be fine. Just going to double check that. 6B. All right. So I just need an extra one of those. So I think that's okay. All right. And now, oh, actually, my content length needs to be a bit bigger. I think it needs to be all of this, right? Yeah, content length needs to be 10. The content length of this one should be this bit. And now we need to count how many bytes are in... Yeah, just the bit that we... Okay, so I think this should do it. If this doesn't work, it doesn't work. So 6C, I think. I mean, let's just send it. We're going to send that. And now we're going to send this. No. Okay, it might, yeah, it might be the H2. I'm not sure, actually. Let's switch it, make sure. Send that. Send that. No. I forgot to turn off the update content length. That's why. That should be fine anyway. Okay, we'll send that. Send that. No. Let me try setting this to 10. I think this is... There's something weird with the way these servers are set up. Or perhaps not. Oh, no, yeah, I don't have a transfer encoding header. That would be why. Pretty important to put the transfer encoding header in there, chaps. We do need a content length though, because the second server will process this entire thing. So hopefully now that works. God damn it. What did I do wrong? Let me just try something really dumb. This shouldn't be the way it works. But let's just try smuggling that. So that's what, 5? Which would make this a content length of 3. I mean that... Yeah, that's not how it's supposed to work. Okay, but now we can at least play with this. We know we have something that actually works here. So let me do gpost HTTP 1.1. Let me do something like x hide and then just hide it. So what happens if we do this now? So this is 1A. 1A, we need to make this go to 4. I don't quite understand why that doesn't work. I'm just going to try this again, to be honest with you. So, content length, and we'll do x, and then we'll do x equals x, and then instead of, we could put 3 there. Let's just try it with 3. Okay, so we have 6B now. No. Weird. I'm actually going to make a proper request. We're going to make a request to robots.txt. Okay. Content length of 8, and we will just do nothing there. How about that? So all the way down to there is 70. Ah, okay. Let's get something that actually exists on this server. Let's get the ICO file. Okay, so we're gonna make the victim, they're gonna send a GET request to the root directory, right? And we're gonna make them load the favicon instead. Or favicon, I have no idea how you're supposed to say that. So we're gonna do this, we're gonna put our cursor there, we're gonna go all the way up to the first G, 71. If we send that, and then it's a GET request to / yeah, there you go. Alright, there was something weird going on. I think I just needed... I think when I set x equals x, I should have... If I increase this to 11, I think that was going to be it. So I think I just had it one lower than it should have been. Oh, when I had the gpost. Sorry, gpost. Let's try this again. 6C. If literally I was one off. I had this set to 10. If I have this set to 10, it doesn't work. I believe actually I ran into this same problem months ago when I was writing this section. So I think the reason for this is, let's just copy this request to here. I just do, okay. So basically, when the second server, so the first server is going to send 6C, so it's going to send all of this, but for some reason, it's weird, like, the second server is going to read this gpost and it's going to continue parsing it till it gets to the content length. And so it's going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So what I found, I think this just is a Portswigger thing. I don't know, but the way it seemed to work, if you only got that many, it would still send this request through for some reason. But if you got the first character of the request, the G, into this content length, it worked fine. So yeah, it's a weird one. But the G is here. Yeah, this is just the way it's processing them. Like, for some reason, if you send this, even though this is a valid request, it just gets lost somehow and it processes this one instead. So I don't really understand why it did that, but what you did was if you were able to get this G, then it processes this entire thing, and then it's left with this, which goes somewhere. Request smuggling is difficult. Okay. So there is a third type of request smuggling, which we'll do, which is called TE.TE. Why did I close that? Yeah, so TE.TE is interesting. So we have CL.TE, which means first server uses CL, second server uses TE. Okay? we have TE.CL equals first server uses users. Why have I not been able to spell? TE second server uses CL. Okay? So we have TE.TE, which means the first server uses TE. Oh my god, why do I keep... How did I do that? Okay, for some reason we just... Oh no, apparently I just scrolled up. First server uses TE. Second server uses TE. No, these won't go. This is a one-time attack. So you attack, you send your payload, the next user in the queue will get your smuggle onto. If you keep sending it, yeah. So this might look odd because how the hell do you attack this? They're both going to read it the same, right? And that's true. Except that even when some servers, even when both servers support TE, some servers are more lenient about HTTP syntax than others. And what do I mean by that? What I mean is the transfer encoding header looks like this, right? Chunked. Okay? Every server that supports transfer encoding will understand that. However, if I put a space before the colon, some servers that support transfer encoding will still recognize that's the transfer encoding header. Other servers will not. And those servers that don't recognize this as a transfer encoding header will use the content length if it exists. So TE.TE isn't really an attack where both servers are using transfer encoding, okay? It's where you are submitting both headers, but you're obfuscating one of the headers, the transfer encoding header, in such a way that one server will process it, but the other won't. Which means that this is difficult, because firstly you need to find one of these, and there can be many. So there's a few where you can have a tab as well. You can have one which has X chunked, right? You can have some servers that accept just the word chunk. And there are some where if this is all caps, it'll be recognized, but other servers it won't be. So not only do you have to find that, you then have to figure out which server it is. Is it the first server or is it the second server that supports the transfer encoding header in the weird way? So what we're going to do, because this is ridiculous to exploit manually, we're going to use the scanner. Yeah, I wouldn't do this. I mean, I wouldn't do any of this manually, but I'm not even attempt to send this manually. So what we're going to do, we're going to send this to repeater. We're going to turn it into a post just so we can mess around with it. Like I said, I usually do x equals x. Make sure HTTP Request Smuggling is installed, which it's not. So if you go to the BAP store and you scroll down and you go to, I've gone past it. No, I haven't. HTTP Request Smuggler, install. And then what we're going to do is right click on this. Actually, I'm going to take all these stupid headers. I hate stupid headers. Okay, there we go. Send that again. Extensions, Request Smuggler. Request Smuggler, we're going to go to just Smuggle Probe. And so there are a lot. All of these, pretty much. So this massive, basically all the options that are enabled that I'm circling are the different things you can do to transfer encoding headers to make certain servers not understand them. So this is going to send a lot of requests, but I didn't want to disable that. We're going to go enter, and if I go to logger, you'll start seeing stuff. So here you go, look, it's done %45. right? Which is an E, but some servers won't recognize %45. What's the next one it does? Let's see. Transfer encoding chunk, I already talked about that one. Transfer encoding, not only with a space before the colon, but also a new line. Transfer encoding with chunked in quotes. I think it's found it actually. Oh, there we go. Transfer encoding, most of it in all caps, but the first one not. There we go. Transfer encoding with another transfer encoding header that just says identity. So there's a few. So what it's doing for each one of these, it's trying to figure out if it's the first server or second server that's vulnerable. Like I said, this attack takes a ridiculous amount of requests. So where did we start? We started down at 180. So it's already done 62 requests. And it hasn't found anything yet, I think. Which one was it? It's 0A8. So it's this one. It'll appear here. But it'll also appear if you go to the extension itself, the output. So it'll appear here as well. But the person who was asking about how you can exploit this. So generally speaking, a lot of the time this isn't exploitable, but there are occasionally applications which are. The neat thing about it is because you can smuggle an entire request, you can smuggle your cookie, right, into another person's request without them seeing your cookie. So how you would exploit this generally is you would find some functionality of the application that lets you set values or lets you store text somewhere. That might be like a profile, like a bio. So imagine you have like a bio where you can submit a massive amount of text. And what you would do is you would smuggle an entire request, including your cookie, and the last bit of the request would basically be like, and bio equals, right? And so that would then get smuggled onto the top before their request. So the contents of the bio parameter would be their entire request if you set the values correctly, which means that they would basically be storing their entire request with their cookie and any other information that was in it into your biography on the application, at which point you just have to wait for the attack to complete, refresh your biography page, and there you go. It found a possible TE.CL. So basically it's a transfer encode. So the first server will always respect these. So both servers will use transfer encoding headers if it's there. The first server won't care that you've got an additional one set to identity. The second server will care. It doesn't think this is valid, and so it'll use the content length. Okay, so how we exploit this, we need to figure out what we need to do, actually. We need to just do gpost again. So what we're going to do is we're going to use, basically, you go to wherever the issue is, you click request 1, you go to extensions, request smuggler, and then there'll be a smuggle attack. It'll either be CL.TE or TE.CL. In this case, we need TE.CL. And it'll open Turbo Intruder. There are scripts to do this as well, by the way. And basically, all you need to do is change this. So we'll write post. We will copy the host header from here. And that's it. So if we just click attack, it's going to basically send our payload and then spam a bunch of requests. And hopefully at some point we will get, maybe not. Oh, gpost. Might need to do the gpost. So I'll put the G there now. There we go. So I can hold. So the first request it sends, so sometimes because of the way this works, it basically it will queue up a ton of requests and then send them all at once. So the first request you send may not actually be the first request. So here it is. The second request is the one with the payload, right? And then this request, which is sent directly after it, it sent a post request with just a regular body, but got smuggled. Okay. Then it keeps doing this, so it'll set at some point it will send the payload again. It's possibly this one actually. Yeah, there, and it'll just generate it again. Okay. So this tool is awesome. This is Turbo Intruder. There are a bunch of scripts for doing this, but it'll you see how you just have to put your request and it will calculate everything for you. On the screen are my socials. Please follow me on Twitter, join the Discord server, subscribe to my YouTube channel, and of course follow me on Twitch to get alerted when I go live. You can also find all these links in the video description.